Okay, so let's have a look at this one. So we've got a vertical rope AB, has its MB attached to the top of a scale pan. The scale pan has a mass 0.5 kilograms, carries a brick of mass 1.5 kilograms. The scale pan is raised vertical upwards, constant acceleration 0.5 meters per second squared, using the rope AB. The rope is modelled as a light and extensible string. And I'm being asked to find the tension in the rope AB and the magnitude of the force exerted on the scale pan by the brick. So let's add some forces onto the diagram. So I've got a tension there, I've got a weight from the scale pan which is 0.5 G, and I've got a weight coming down from the brick which is 1.5 G. Okay, now the key with questions like this is making sure that you're dealing with the correct part of the system. So let's deal with the tension first of all. So for A, I'm going to consider the whole system. Sorry, on here I should have written 0.5 meters per second squared so we can see everything. So the whole system, I'm going to do F equals ma in an upward direction. Okay, so nice and simple. So I've got T on the whole system, I've got 1.5 G minus 0.5 G. So that is the resultant force acting upwards on there. I've got the mass, so the total mass of the system is 2 kilograms, so at 1 kilogram and half kilogram, and the acceleration is 0.5. So T equals 2 times 0.5 plus 2G, which is equal to 20.6 newtons. Okay. Right, now nice and straightforward. So the second bit asks us for the magnitude of the force exerted on the scale pan by the brick. Now the way to approach something like this is to think about Newton's third law. So the magnitude of the force exerted on the scale pan by the brick is equal to the magnitude of the force exerted by the brick on the scale pan. So we can think of it either way. So actually what I'm going to do is I'm going to think about the brick. Either of those options would work, and actually I think probably if we do it on the brick then it becomes fairly straightforward. So I've got a brick which is 1.5 kilograms, so I've got a 1.5 G force acting down. I have a force acting up from the scale pan on the brick. This is equal to the force exerted by the brick on the scale pan. They're equal because it's Newton's third law says they're equal. So I can calculate the force exerted by the scale pan on the brick, and that is equal to the force exerted on the scale pan by the brick. Yep. So that is what I'm going to do. So I've drawn another little diagram just with the brick isolated and the forces identified. Okay, so I'm going to do this. Okay, so I've got R minus 1.5 G equals 1.5 mass times 0.5 acceleration. Excuse me. 1.5 times 0.5. So R equals 1.5 times 0.5 plus 1.5 times 9.8. That's what's going to go in the calculator. 1.5 times 0.5 plus 1.5 times 9.8. So that's 15.5 newtons to 3 significant figures. Okay, and that's the answer.